technique of creating new classes from existing classes. Okay, the features, acquiring features of one class into another class. That concept is called as inheritance. So the terminology associated with the inheritance is that, so there will be a superclass, there will be a subclass, and the relationship between the superclass and the subclass will be an either relationship. And so as you look into the hierarchy of inheritance, the topmost, it's a top-down approach where the generalized classes will be there on top of the hierarchy, and the specialized classes will be there at the leaf levels of the hierarchy. Okay, and how do you create create inheritance in Python? In Python, you will be creating the inheritance by giving the base class name inside the parentheses after the child class. Okay, so this is the syntax of how do you create inheritance. And what are the different types of inheritance? There are 4 types of inheritance that Python supports. The first one is single inheritance, second one is multi-level inheritance, and the third one is hierarchical inheritance, and the fourth one is multiple inheritance. Okay, and we started off with the single inheritance. Coming to the single inheritance, you will be having one base class and one child class only. Okay, this is how you represent it in the diagrammatic form. So you'll be having a base class here and the derived class. So always remember that the arrow mark should be pointing to the base class, meaning that the derived class is acquiring the features of the base class. What I have done, I have taken one class which is person. Okay, so say that this is the existing class, and from this existing class I can create a new class which is professor class. I have created a professor class in the morning, and then which acquires the features of the person class, because the relationship is that professor is a person. So what are all the data members and the member functions that are there in the person class will be now available to the professor class. Okay, right. So individually, if you want to access the person's details, data from the person class, you can actually do that also. Okay, so I have shown you all this in the morning. Now, what is polymorphism? You know that poly means many, okay? Morphisms means forms, okay? So poly means many forms, okay? So one method existing in different forms is called as polymorphism, and this is one of the very important features of object-oriented programming, along with inheritance and encapsulation. And so the definition of polymorphism is that a function or a method existing in many forms. Okay, right. So what is the advantage that you get by using polymorphism? By using polymorphism, like the programmers, like you and me, like whoever writes a program, can assign a different meaning or usage to a variable or to a function or to an object in different contexts. Okay, right. So they can use the same name, but the functionality can be different. Okay, so the same name can be referred to different functionalities. So how polymorphism is different with inheritance? Yes, inheritance is related to classes and hierarchies. Okay, so you talk about like how a class is related to another class, whether it is child class or the super class. We won't be talking anything about the data part or the methods that are there inside the class, but we'll be discussing in inheritance. We concentrate mostly on the classes and the hierarchy. Now coming to polymorphism, polymorphism is related to methods. Okay, so it's all about methods. How many forms the methods can be. Okay, so it is purely a method based concept, whereas inheritance is a concept which is related to the classes. Okay, right. And so the in Python, method overriding is one way of implementing polymorphism. There are two ways of to achieve polymorphism. The first one is method overloading, and the second one is method overriding. Okay, coming to method overloading, I already told you that method overloading is not supported in Python. Okay, to achieve method overloading, you need to have a different technique which I already have shown you how you can achieve that concept by different programming logics. Okay, now coming to overriding, yes, Python supports method overriding, and we'll look into that concept. I'll show you with an example. Before getting into the example, let us look into the differences of inheritance and polymorphism. Inheritance is one in which new class is created. That's what we have seen the definition right now. That inherits the features from an already existing class. Okay, so I already told you the benefit that you get with inheritance is reusability. Okay, so you can use the reuse the concept of the classes, the same class, you can use it in many other applications. Okay, so wherein you need not write all the methods or the data again and again. Rather than that, with one class having the concept, you can just use it in your application. Okay, right. These are like instant things. Okay, so which are already available, you're keeping and you're using it in your class. And whereas coming to polymorphism, like it means that the definitions, okay, so it is multiple forms, which we already have understood that polymorphism relates to methods. So we are talking about multiple forms of a method over here. Okay, right. And inheritance is basically applied to the classes, and this is methods. Okay, fine. And next is inheritance supports the concept of reusability. So this is the benefit that we get. So reusability actually reduces the code length in the object-oriented programming. Any application by fact you take, whenever you're reusing the code, what you're doing is you're actually reducing the number of lines. Now coming to polymorphism, it allows the object to decide which form of the function to implement at runtime as well as the compile time. Now, as I said, like there are two ways of polymorphism. The first one is compile time, and the second one, I mean, overloading, and the second one is overriding. Overloading is a concept like wherein the function, which function to pick, is decided during compile time. And overriding is where the function to execute will be decided during the runtime. I already told you overloading, wherein you are having two methods with the same names, but your compiler will not be confused because the number of parameters and the type of parameters will decide like which function to call. Anyways, Python do not support, so we are not discussing about that. And the next one is like runtime polymorphism, wherein it's a concept of overriding, and I'll show you the example. Okay, and the next difference is that inheritance can be single inheritance, hybrid. Hybrid is nothing. Okay, so which is a combination of single and multiple, then it becomes a hybrid concept. Okay, fine. So there are four kinds of inheritance, like single, multiple, hierarchical, and multi-level. And whereas it can be like here we saw like compile time polymorphism and runtime polymorphism. These are very, very important interview questions. Like what is compile time polymorphism called as? The compile time polymorphism is called as method overloading. What is runtime polymorphism called as? Runtime polymorphism is called as method overriding. Okay, so these are very, very important concepts. We also call it as static polymorphism and dynamic polymorphism. So there are different names to it actually. Okay, right. So before getting into overriding, let me give you another concept which is called as the super class, super function. So what is super? Okay, super is used to actually refer to the base class. Okay, so super is used to refer to the base class. If you remember, this is the same program that I have already shown you, the person and teacher program that I already have shown you, wherein in place here to call the superclass init method. In my example, when I have shown you, I have written person, right? I said person dot init, and then I have called it, if you remember. So let me show you that program so that you can recall what I have written. So just look into this program. So this is the program I already have shown you, right? I have executed this program and I have shown you. So just take a look at this particular one. So what did I write to call the superclass init method? So what did I write here?
Person dot.
Person is what? Person is the name of the superclass, right? Person is
Yes,
the
no.
superclass, and then I have put a dot, and then I have written init in it, and then this is the name of the method anyways. And here what did I do? I have given self also. Okay, so I have written self and then n and a, the rest of the arguments that I want to pass. Okay, so this is what I have done. And to call the display method, what I did before the display method, I have written person. Okay, because I want the display method that is there in the person class. Okay, so this is what we have done. What exactly does it mean by person? Person means that I want the super class, some method to be called, right? So person is the super class, teacher is the class, and person is the base class of teacher. Okay, so we have been using person or the name of the superclass. Rather than using the name of the superclass, you can also use the super method. Okay, so now what I'm doing here is instead of writing person or the name of the superclass, I can simply write a super over here. Okay, and when I'm using super method, I needn't pass self to the init method. Okay, so you can see here I needn't pass self because it knows like it is called on this particular object. So super method is also can also be used instead of the name of the base class. Okay, both are correct. Okay, so the previous program I have written is correct and this is also correct, but maybe in your examinations they'll ask you to explain super method and with an example. So in that cases, you need to show the example in this manner. Okay, so there I have written person dot underscore underscore init underscore underscore. Then I said self comma n comma in. But look how I have written here by using the super. Super means super class. Same way, when I want to call the display method, I said super and I'm not passing self. See, okay. So this is how I'll be using super. So when I have tried to print the display teacher, so what happens inside this method? It is calling the super display. So the name and age is printed, and later on the area experience and the research area is printed. So this is the output that we have got. Is it clear with super, everybody?
Yes, ma'am.
Yes. Okay, so now let us look into the second type of inheritance, which is multi-level inheritance. Okay, so I'll show you this program with execution. So before that, let us understand what is multi-level. So the first type is over. What is the first type of inheritance, which is single inheritance? Single
Single.
inheritance, right? Everyone, is it clear with everyone? What is single
Yes,
inheritance?
ma'am.
Yes, ma'am.
Right. Okay. So now this is multi-level inheritance. What is multi-level inheritance? Say I'm having three classes, class 1, class 2, and class 3 and class 4. This level can be any size deeper. Okay. So it can be any size deeper. It can be 4 classes lined up like this or 10 classes lined up like this. Any number of classes, multi-level. Okay. So multi means n, right? It can anything. Okay. So any levels you can have. In the previous case, when I said, I just said single level, single inheritance, where I'm having only one parent and one child. That's it. But here you can have something like this lined up. Okay, so there is a class 1 and class 2 and class n. Class n is derived from class 2 and class 2 is derived from class 1. Okay, so this is called as multi-level. So I'm having many levels of inheritance. Now let me tell you the concept, what will be there inside this particular inheritance. Now, as I said, like it is, imagine that this is your parent and this is you. Okay, so class 2 is you and this is your child. Okay, fine. Now, your child can access the property of you as well as your parents, but you cannot access the properties of your child. Okay, so there is no law also like that. Okay, the parent cannot get the properties of the child. Only the child can get the properties of the parent. How mean it is. Okay, fine. So this is the concept of multi-level inheritance, meaning that here the class n can acquire the qualities of class 2 and also class 1, and class 2 can acquire the qualities of class 1 only. Okay, and class 1, it's an individual class, it doesn't inherit from anything, so it is independent, it just have its own features. Okay, so this is multi-level inheritance. So from the object of class n, I can access the methods and data of class 2 as well as the methods and data of class 1. Class 2 can access with the object of class 2, I can access the methods and data of class 1. That's it. Okay, but in reverse it's not possible. That's why I told you put the arrow mark like this. Okay, so when you put an arrow mark like this, you'll clearly understand that this can access this one. Okay, but in reverse it's not possible. It's unidirected arrow, right? It's not a bidirected arrow. Okay, both ways it's not possible. Only class n can access the methods of class 2 and class 1 because it's accessing because it means that it's a relative property, right? Class 1, from class 1 class 2 is there, from class 2 class n is there. Automatically class n can acquire the features of class 1. Okay, that is possible. So this is multi-level inheritance. Is it clear with multi-level inheritance, everyone?
Yes, ma'am.
Okay, so now let me get back to the terminal and show you the execution. Okay, I'm having something like this. Okay, so this is self, and then I'm saying let us make this as grandparent. Okay, and then the name of the grandparent. Okay, so grandparent name. Okay, fine. So I said self dot grandparent name is equal to grandparent name. So that's it. I do have something like this in the grandparent class. Now I'm saying parent class. Okay, so I'm just saying P. Okay, but P is inheriting the properties of grandparent. So now there is a relationship between the parent and the grandparent. Okay, right? Okay, so this is parent, right? Okay, not only P, I will also call the grandparent. Okay, so I'll say GP. Okay, and then I'll call the superclass. Okay, so how do I call it? So I'm saying GP dot underscore underscore init underscore underscore, and then what I should say? I should say self comma. I'm saying GP. Okay, so this GP is passed over here. Okay, so this is regarding the second level. Okay, now coming to the third level, so wherein I'm saying it is son. Okay, so I'm giving S over here. So it is inheriting the parents properties. So I said P over here, and then so here I'm also extra having the son name. So I'm saying X. Okay, so I'll say self dot son is equal to son. Okay, and then I'm calling the parent. Okay, um, okay, right. And so I'll pass parent as well as grandparent. Okay, all the three I'm passing, okay, to the parent. Okay, fine. So what else we'll do? Okay, so you can see that in the son class, we are taking all the name of the son, name of the parent, and name of the grandparent. You are initializing the son over here, and then you are calling the parent over here. So to the parent, you are passing the parent one, and so this is capital letter. Okay, so small or capital, it's okay. Fine. Okay, so I'm passing it over here, and GP also I'm passing. Okay, so this class is taking the second level is taking P and GP, and which will be assigning P, and then the GP is passed to the parent again. Okay, so the grandparent name is assigned. I also have a display method over here, so I'm saying def. So I'll say display. So wherein we'll be displaying all the names of the three generations. Okay, so I'll say print. So you can say uh, name of son. Okay, so what's the name of the son? So it is self dot s, right? Okay, in the similar way I can also print the name of the parent and the grandparent, okay, in the display method. So I'm having three display methods over here. So this is the parent. So what's the name of the parent is taken as P. Okay, and also what is the name of the grandparent, which is GP name, right? Okay, so GP name, and parent is P. Okay, so son is S. Okay, fine. And then this is the grandparent, right? Okay, so this is all called as multi-level inheritance. Now I'm creating an object. So I'm saying O is equal to, so I'm creating the class of son. So I'm saying S. Okay, and then I'm passing all the three names. Okay, so maybe I'm saying Ranbir. Then I'm saying Rishi. Okay, and coming to the parent, I'm saying Raj. Okay, fine. And so then I'm calling the display method. So I'm saying O dot display. Okay, let me execute and show you. Okay, this is capital P. Okay, girls, can you see the output now, everyone?
Yes, ma'am.
Okay, did you understand the program?
Yes, ma'am.
Okay, so what is this? This is the first level, right? Okay, so this is the first level, and this is the grandparent class. Now this is the next level wherein the name of the class is P. P is inheriting the properties of the grandparent. Okay. And this is the third level wherein this is inheriting the properties of the parent. And you can see that in the child class. Okay. So you can imagine this to be A, B, C. So in the son class, you can see I have also access to the grandparent variable. Okay, I have accessed the grandparent variable. That's what I told you. Okay, so when you're having inheritance, this C automatically, even if it is not directly the son of this particular GP, through P it can inherit the properties of the grandparent. Okay, so this is multi-level inheritance. This program is to demonstrate a multi-level inheritance. Okay, so like this you can have n number of inheritances. Okay, you can have how many ever levels you want, you can have. Is it clear, girls?
Yes, ma'am.
Is it clear, or you want me to explain
Yes,
more
ma'am.
clearer?
Yes, ma'am.
Just take a look at this. I told you that the child class can access the properties of the parent class, but the parent class cannot access the properties of the child class. Here what I did, I have created an object of the GP class, and I am trying to access the display method that is there in the child class. Now what it is telling, it's giving me an attribute error saying GP object has no attribute display. So the child class can access the properties of the parent class, but the parent class cannot access the properties of the child class. Okay, so this is very, very important concept for us to understand. Okay, I got everything. Okay, so from the child class, I'm able to access. Okay, I got all these answers. But when I try to access it with the parent object, I'm not able to access the child class methods. Okay, so this concept is called as multi-level inheritance. Fine. Okay. Now we'll see the next concept, which is hierarchical inheritance. Okay, so what is hierarchical inheritance? Hierarchical inheritance means that, let me show you the diagram. Okay, fine. So this is the hierarchical inheritance. Hierarchical inheritance is that, for example, I'll be having one base class, and this class can be derived by many other classes. Okay, so there can be many other derived classes from one class. Say that I'm having a class A, and B can inherit the properties of A. C also can inherit the properties of A, and D also can inherit the properties of A. Okay, so this is hierarchical structure. Like in your tree structure, you have this tree structure, right? You are studying in your data structures, right? So there will be a root, and from the root, like you will be having a left child and the right child. Okay, a binary tree. Okay, but if it is a normal tree concept, like you can have n number of children. So this kind of concept, okay, so which is called, that's why tree concepts are called as hierarchical data structures. So in the similar way, like you can have that there is an class A, and from class A you can derive n number of base classes. So this is possible. To show that this is possible, hierarchical inheritance is possible in Python. Okay, so I hope you understood this, and let me show you this with an example. So it means that I'll be having one class, and from one class I'll be I can derive many other classes. Okay, so let us take the example of the professor, and that example, and then let me show you the output of it. Is it clear with hierarchical inheritance, everyone? Is the concept clear?
Yes, ma'am.
Having a class person, and this is your teacher class. Okay, so which is inherited from person. Okay, so now I'll write another class. Okay, so which is class student. Student is also a person, right? So student is also a person. So what I'll do, I'll inherit the properties of person over here. Okay. So student also will be having a name and age. we will also have name and age. So that's why I said student, and the super class of student is person. Okay, so this is also possible. So let me take all this into the student class. Inside the student class, uh, I'll be giving, okay, so the branch the student is studying in, and then some marks. Okay, I'll say marks. No? So N and A are passed, name and age are passed to the super class, and here I am saying the branch. Okay, so branch is equal to branch, and next we have marks, right? So the marks is equal to marks. Fine. Okay, so and this I'll say display student. Okay, so wherein I am displaying the branch is, okay, so which is self dot branch, and this is marks of the student. Okay, marks. Okay, and marks, right? Okay, fine. Okay, good. Okay, like how I have created the object of the teacher, I also will be creating the object of the student. Okay, so inside the student, I have to pass the name of the student. Say I'm saying Aparna, and then the age of the student, some 22, and then I am saying the branch of the student is CSC, then the marks of the student, some 78 or something. Okay, now I'm accessing the display method. Okay, so inside this display method, you can see I called the display method, right? So it will be easy for us to uh, do that because you are just using the code. So I said s dot display student, right? What's the name of the method? So it is display student. That's it. Okay, when I execute this, you'll be getting the answers. Okay, fine. Just look into the details. Okay, so this is the details of the faculty or the teacher, and this is the details of the student. Okay, so what is this concept? So in examinations, if they're asking you to explain about hierarchical inheritance, then you have to write programs like this. Okay, explain the program. So you have to show the syntax and also explain the codes like this. Okay, so here there is one class which is person, and teacher class is also is derived from person, and student class is also derived from person. So here teacher is also using the method and the init method from the person class. Student is also using the display method and the init method from the person class. You can see that if I do not have this inheritance concept, I have to write these two lines inside this program as well as in this program. Okay, so here itself you can understand that you saved two lines of four lines of code. Okay, this concept. What is this concept?
Hierarchical inheritance.
Hierarchical inheritance. Okay, now clearer. So we have covered three concepts now, the inheritance concepts now, and let me show you what is meant by method overriding. Okay, fine. So let me give you that program. Say for example, I'll be just taking two methods over here. Okay, I'll just take one class person and the other class teacher. Okay, fine. And then say I'm having the same display method in the parent class and in the child class. Okay, so this is the concept of overriding a day. Okay, so just take a look at this particular program wherein you are having inheritance. The concept is inheritance over here. Okay, so it's a single inheritance or any kind of inheritance you have, and then you have a base class. So this is your base class. Okay, and then you have a method inside the base class. So this is the method inside the base class, which is the display. What is the name of the method? What is the name of the method? The name of the method is display. So I'm having another class which is teacher class, and which is derived from the person class. And inside the teacher class, you can see that I'm having one more function which is called as the display method. Okay, So this display method, you can see and take off this for you to understand the concept better. Okay, so I'm having two methods here. In the parent class, I'm having display method, as well as in the child class, I'm having one more display method. The name of the method is same, as well as the arguments that are getting into this particular display method is also same. Okay, both the methods look the same, okay, in terms of names as well as in terms of the number of arguments that enter into the function. Such kind of, and one method is in the parent class and one method is in the child class. We are not talking about the methods which are different with the names and all that. Automatically when the method is different, we are not bothered, it executes fine. But the only problem will come when the methods have the same name. So the name conflict will come over here, and how it is resolved, that's what we are looking over here. Okay, so if they are have different names, in my previous example, that's why I gave different names to the display method. In the teachers display, I said display teachers, and in the students display, I said student display. I didn't give the same name because I want to explain you this overriding concept. Okay, so the concept that I'm going to explain you is the overriding concept. What is overriding concept? So there is an it's a polymorphism concept wherein there two classes are in inheritance, and there is one method in the parent class and also in the child class which have the same name, as well as the number of arguments into these methods is same. Okay, so now you call the concept to be overriding, and the method that is overrided is nothing but the display method. Okay, so the display method is overridden. When you say overridden, okay, so when you say that there is an overridden method, okay, so you'll be using this concept, this terminology in in object oriented concepts. We'll say that it's an overridden method. Okay, so what does it mean by overridden method is like there is already a method in the base class, and we are taking the same name, same method, the name of the method and the arguments, everything same, but into the child class. Then you call that method as overridden method. Okay, so when do you call a method is overridden?
Same method is present in when two methods that are present in parent class as well as in child class with same name and number of arguments are same, then we say they are that method is overridden.
Very good. Always. So here display method is considered to be overridden. Okay, say for example, I'm having one more method, so which is def sum and okay. 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 Is some overridden method? It's not overridden method. It's an individual method inside the teacher class. Okay. So when the name of the method matches, then only it is considered to be overridden method. Parent class. Here the display method is the overridden method. Okay. Now let us see what will happen when I execute it. Okay. For example, I'll take off this. Okay. I'll put comments in front of this display inside the child class. Okay, ఇది లేదు, ఈ మెథడ్ ఉందా ఇప్పుడు?
No,
No, ma'am.
no.
So I just have commented it. Okay, so now I have created the object of the child class, which is teacher, and I'm calling the display method. Okay, now let me show you the output. Okay, so what did I get? What is the output over here? So I got Sudha and 30, right? Meaning that, so the display method in the parent class executed. Antena?
Yes, ma'am.
Is there any display method in the child class?
No, ma'am.
No.
I have commented it, meaning that there is no display method in the child class. There is one display method in the parent class, and through whose object I am able to access the parent class display method?
Child class object.
Child class object. Through the child class object, I'm able to access the display method of the parent class. Okay. Now I have written method which is display method in the child class. Okay, fine. Now let me execute and show you the answer. What did I get? What did I get? This is the entire answer. Nothing in front and nothing after. What did I get? I got the experience and the research.
Experience and research.
Experience and research area.
Which display method it is? It is the child's display
Object.
method.
Child's
Child,
child.
ma'am. Child.
child's display method, right? Okay, so you're not able to access the parent display method. When there are two methods with the same name, you cannot access the parent's display method. That's why we say that it is overridden. Okay, so you're overriding the display method. So there is no way for you to access the display method of the parent. Okay, unless and until you use some super over here and call the display method, you cannot directly call the display method of the parent with the child object. If the child object is having the same display method, you cannot access the parent's display method. Such kind of methods are called as overridden method, and preference will be given. Here I'm having two display methods. One is the parent class and the other one is the child class. When I say the display method, since I'm calling it on the object of the child object, the preference will be given to the method that is written in the child class. So that is why I have got experience and the research area, which is there in the display method of the child class. If there is no display method in the child class, the display method, it will check whether display is there in the child class or not. Since display method is not there in the child class, it will look whether that method is available in the parent class. Yes, display method is available in the parent class. It will return that and display whatever is there in the parent class. Inheritance means that the teacher class is also having the display and the init method in itself. Inheritance is that. Okay, meaning that all the data that is there in the person class except for the private data, the child class can access everything that is there in the super class except for the private data. Okay, private methods or the private data. Other than that, all other data is accessible in the child class. So here you cannot access the display method of the parent because there is already a method inside the child class with the same name. So there is an overridden method in the child class. So that's why the parent class display method is not called. Is this concept clear to everyone? Overriding?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, very, very important concept in your university examinations and in your placements. This question is a very quite common question. Explain overriding with an example. Explain which method will be called when there is an overridden method. The method in the child class will be called. Okay, so this should be your answer. Which method is called? There is an overridden method, and which method is called? Which method is called? The parent class display method or the child class display method?
Child class
Child
display method.
Child.
Display method. Okay, for example, I'm creating a method, or I'm creating an object of the parent over here. So I'm saying parent person, and then I'm passing some name and some number over here. Okay, so then I say p dot display. What did I do here? What did I do here?
Calling display function by using object of parent class.
So then which method is called?
Parent class display.
Parent class, ma'am.
So that is the concept which we already know. Okay, but through the child class object, you are not able to call the display method. Is the concept clear?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Yeah, yeah. So that's it, girls.